Hey everyone, sorry I'm not there today. Hopefully you can watch this video and it'll help you get through some unanswered questions that you might have had. Today we're doing 8.2.2 and we're going to do problems 8-59 through 8-63. So it's just a small handful of problems here. A few of them will be reviewed, but similar to yesterday's lesson of 8.2.1, how we expanded our exponents, and then from there, how would we be able to simplify it? Okay, so again, we're focusing on exponent rules for today. Okay, go ahead and take about a minute or so to read this prompt. While you're reading this prompt, make sure you're asking yourself these three questions. Okay, go ahead and pause the video right now if you need to read that prompt. Okay, so hopefully if you paused it and you came back now, and we're going to read these three questions together. Okay, it says, the first one says, what part of the expression is being raised to a power? Okay, what part of that expression is actually being raised to the power? Because not everything is going to get raised to the power, only part of it. Second question is, what are the factors? Meaning, what will multiply into my actual term or expression? And then how can we rewrite the expression to have fewer terms, right? Basically, how can we simplify it? Instead of repeating things unnecessarily, how can I write it in a shorter fashion? Okay, we're going to go ahead and start out at 8-59 right now. And let's take a look at this. So we have 10 squared times x cubed times 10 times y for problem A. If you recall, this 10 has a power of 1, that y has a power of 1. Okay, so if we're multiplying, remember everything is being multiplied here. Multiplying is commutative, so it doesn't matter in which order we do it. We're going to multiply 10 squared times 10 to the first. So there's two 10s here, and there's one 10 there. I should get 10 to the third, as we talked about yesterday and the day before. Okay. Then I have x cubed. I can't combine it with anything else, so I'm just going to write x cubed. And then I have y to the first, and I cannot combine it with anything else, so I'll just leave it as y, which is y to the first. And there is your answer. Okay. If you recall, we have the same base now. We can just add the exponents. This is going to be 20 to the 3 plus 8 would be 11. Remember, if we were to expand this, that's 20 to the third power right there. That's what's being represented by 20 to the third power. Okay, and then I'll choose another here. If we do 20 to the 8th power, it's 20 times 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 20. You're essentially just counting how many 20s do I have that's multiplying each other. Okay, so I've got 3 in red and then the 8 in the green. I have a total of 11, 20th to the 11th. Okay, and the last one gets a little bit sloppier, but same type of concept, right? We're going to start in ABC order. So we're going to do x, y, then z. So let's look at our x values. I have x to the second times x to the third. I've got 2 here and 3 there. So I have a total of 2 plus 3 is 5. Okay. Then my y's, if I'm going to look for, I'm done with the x's. I'm just going to cross them out so that they don't get in my way. So I have y to the second power. I don't have any more y's, so I'm just going to write y to the second power by itself. So I'll cross that one out. And then my last one, I have z to the second times z to the fifth. 2 z's and 5 more z's gives me 7 z's. Okay? And that is 8-59. Let's move on to the next one. If you need to pause this to take a look at our work or rewind it, please do. Okay. Let's go to 8-60 right now. Okay. 8-60 says, Aaron wants to rewrite the expression 5 squared x squared times 5 to the 4th x to the 3rd in simpler form. And she started expanding it right there by doing 5 times 5 plus x times x plus 5 times 5 times 5 times 5 plus x times x times x. And then she simplified it and she got that. Question is, do you agree with her work? Why or why not? So at this point, you would work with your team. If you agree, write why you agree. If you disagree, write why you would disagree. Okay, so again, at this point, you can pause the video, and hopefully you work on it for a couple minutes or so. See if you agree or if you disagree, and come on back. Okay, hopefully at this point you've paused it and you just came back after trying to determine if Aaron was correct or incorrect. Okay, so at this point, if we recall, we'll go back to the original problem here. I'll use green here. I've got 5 squared next to x squared. When terms are next to each other like that, there's no sign in between them. We assume that it's multiplying. Okay, the assumption is always going to be multiplying. So all of these are multiplying each other. Let me erase that and start over here. It's 5 squared times x squared times 5 to the 4th times x to the 3rd. And as we previously mentioned, multiplication is commutative. So it doesn't matter the order. I'm just going to multiply 5 to the 2nd times 5 to the 4th. And that should give me 5 to the 2 plus 4. Oh, hold on 1 second. 2 plus 4 is 6. Okay, so I'm done with that. Now I have x squared times x to the 3rd. 2 plus 3 is 5. So I get 5 to the 6th, x to the 5th. That should be your final answer, okay? So the problem with Erin's work is she started to add them. There is nothing in this problem, so I'll go back to the original problem here. Nothing in that problem said to add, right? But what did she do? She started to add. So that's going to be a problem, okay? They're all multiplying each other, so we should keep it as multiplying. So again, let me rewrite the answer as 5 to the 6th times x to the 5th. Okay, there's your final answer. Okay, let's move on to problem number 61. So 61 gives you this table. And this table is actually on the back of the handout that you guys got on Monday from 8.2.1. This table is the other one, which is should show 8.2.2 at the top of it. If you're period 1, you didn't get that backside of it, so you'd have to go get the handout right now. So make sure your resource manager grabs this only if you're from period 1, because you guys did not get the double-sided handout. So let's read this together. It says, when a number is raised to a power and then raised to a power again, the result follows a consistent pattern. Complete this table and expand it into factored form, then rewrite it with new exponents as shown. Okay, so let's take a look at this. Here's the original problem. I have 5 squared. And now you're asking yourself, how many times do I have 5 squared? And it should be 5 times, right? An exponent is whatever is being multiplied times itself that many times. So what's being multiplied times itself is 5 squared. Well, how do I represent 5 squared? 5 squared is really 5 times 5. So you're saying, how many 5 times 5 do I have? Well, let's count it. I've got 1 5 squared, 2 5 squared, 3 5 squared, 4 5 squared, 5 5 squared. So once you factor it out and expand it, you can actually count how many 5s you have. So again, I'll count it with another color. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and therefore I have 5 to the 10th is my final answer. It's simplified. Okay, it is much easier if you actually expand it and count it just like I did there. Okay, so again, at this point, go ahead and pause the video, work on it maybe for about 3 or 4 minutes, see what you guys come up with. I want you guys to expand it into factored form. So you're basically going to fill out this entire middle column here, and then when you're done, give me the final answer. Okay, so go ahead and pause it right now and take a break, and hopefully when we come back, you'll have the same answer as I do. Okay, so hopefully you've come back from taking a break, worked on it for a few minutes, and you got you filled in that table already, and here are your answers. Okay, again, all I did was I've expanded this left side right here, and I've just basically wrote out how many of those numbers and letters that there are, and at the very end I just tallied them up pretty much. Okay, so again, at this point, if you need to double check your answers, go ahead and pause the video and check it and make sure you're doing it right. Okay. All right. Let's move on to question B here. Question B says to visualize 20 to the third raised to the 8th power. Okay, what is being multiplied? That is, what is the base? How many times is it being multiplied? Okay. Use the expression you visualize to help you rewrite the expression in simplified exponent form. Describe in detail how you figured out what exponent to use in the simplified exponent form. Okay, so if you really wanted to, you could write 20 times 20, times 20, that's 20 to the third power, and you could rewrite that 8 times, right? But as you know, that's going to take you a long time. Okay, so what's the fastest way to solve it? All right, so again, let's put our brains together and think here. Instead of writing this 20 3 times there, and then another 3 times, and then another 3 times, and then another 3 times, 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 right? What's the faster way to do this? How many 20s will we end up having? Okay, so again, at this point, go ahead and pause the video if you want to try to figure this out, and then come back in a few seconds. Okay, so hopefully you guys have worked this through. Maybe you talked to a partner, maybe you did it by yourself, no big deal. And you've realized at this point, essentially, you've got 20 to the third 8 times, right? And if you had expanded it out, you would get 8 sets of 320s. Okay, so if you got 8 sets of 320s, you'd have 24 sets of 20. Okay, so essentially your answer would be 20 to the 24th power. Okay, so how did you get that? So think about that as you, if you look back, how did I get 20 to the third power to the 8th power and get your final answer as 20 to the 24th power? Okay, hopefully you can come to that conclusion yourself. Okay, let's move on to 8-62. And 8-62 says, in problem 8-59, the first problem we did today, you simplified 20, excuse me, 20 to the third times 20 to the 8th. How does that compare to the one we just did right above of 20 to the third to the 8th? Okay, because there is a very distinct difference, and you guys need to see and understand what that distinct difference is. So again, what's the difference between that and that? Okay, go ahead and pause the video right now, take a look at it, and see how those two are different, because you are going to get different answers. And as you've already done, you do have different answers. Okay, how are they different? Why are they different? So think about that. Don't just look at the answer and see that they're different. Try to understand why they're actually different. Okay, so again, the answer to that one is going to be 20 to the 24th, like we just solved. And then at the beginning, the answer to this one is 20 to the, I have 3 of them, and then 8 of them, and I have a total of 11 of them. As you can see, they're vastly different answers. Make sure you understand why they're different. Okay, we're going to do the last problem of today, 8-63. And this is the trickiest part. Very common mistake here. I want you guys to analyze our 2 examples here. I have the in parentheses 2x raised to the 3rd power, and then I have just 2x to the 3rd power. Okay, big difference. Again, excuse me. In parentheses 2x, both of those are raised to the 3rd power, whereas my other one, I just have 2 times x raised to the 3rd power. Okay, so they look very similar. Are they? Are they exactly the same thing, or there's a slight difference? Okay, so Heidi is wondering that. So there's only one way to find out. Let's just expand it. Okay, this 3 tells me everything inside the parentheses is multiplying itself 3 times. So I get 2 times x times 2 times x times 2 times x. Well, how many 2's do I have? I have 3 of them, so it's 2 to the 3rd. How many x's do I have? I have 3 of them, so it's x to the 3rd. Okay, you can actually multiply 2 to the 3rd and get 8. So your final answer would be 8x to the 3rd. Okay, well, now we look at this example. That example, the 2 has its own exponent. If you recall, that 2 isn't in a parentheses like the one on the left was. Okay, the one on the left, right here, rebox that, is in a set of parentheses. So that means the 2 will get that 3rd power, and the x will get that 3rd power, right? The 2 and the x. We'll go back to the problem here on the right. The 3rd power is only attached to the x. That 2 has its own power. That 2 has an invisible 1. So this, if I were to simplify this problem, it would actually just be 2x to the 3rd. It's already simplified. There's nothing else that we could do. Okay? So, yeah, just we're doing problems A, B, and C right now. We just answered A pretty much. We kind of answered B, right? It says show that she is correct by expanding this expression. It wouldn't be very difficult to expand it. It would just be 2 times x times x times x. Okay. So, are these the same? Why or why not? I want you guys to explain that in your notes. And that will conclude today's lesson. Make sure you guys do your homework tonight, your summaries, your repetitions, and I don't believe there are methods and meanings, but I could be wrong. Go ahead and scroll down there and check. Hopefully you guys do your homework. If you have any questions, be sure to ask them when we get back to class the next day. All right, have a good one, and I will see you guys tomorrow. Bye-bye.